So the first step, also we will pick a three-phase voltage base, okay? So it will not be the single phase complex power base that's in the single phase system. So there you can see that S with the untitled three-phase base. And also we will choose the single voltage base, but for different whatever. Okay, from here, okay? So please pay attention. Please notice that there will be the voltage here on 9 to 9 voltage, and then I can make the impedance base. Okay, so Z equal to the V squared divided by the S. Okay, so the SAT formula V is compared with the single phase. Okay. Okay, so here is 9 to 9, okay. Also, we will assume that here's the three-phase system is wire connection, okay, wire connection. So 9 to 9 voltage is equal to the square root 3.
Yes,
and then
like
one
the
is it is the phase voltage. That's 9 to 9 voltage.
So make
Okay.
it like the neutral.
And you can see that the three-phase complex power is equal to 3 times the complex power of each phase. That if each phase is in balanced, so it's 3 times this. Okay, and square root of 3 and square root will get also 3. Okay, 3, and with here. Okay. So we'll get this. So the voltage base of the line to the phase voltage base square divided by the complex power base of the one phase. So you can see it's very similar to the, or it's actually the identical with the single phase expressions. Okay, you can see. Right? So please pay attention. Here is the phase voltage, and here is the complex power for one phase of one of 3 phases. Okay, so you see this is identical with the corresponding single phase. Okay. So the current base, you see the current equal to the complex power divided by the voltage. And so we will convert these 9 to 9 voltage to the phase voltage, okay, 9 voltage to the phase voltage. So we will do another square root of 3. And here is the 3 times each single phase complex power, 3. So it will be also the complex power of single phase divided by the phase voltage. Okay? So you see, yeah, that's the identical for this situation. So the 3 phase, the impedance, the current, is the same with the corresponding phase. Okay, that's the same expression, same formula compared with the single phase system. Okay, so kind of easy, right? Okay, so I will give you 3 phase per unit examples. Okay, so we'll still calculate the parameters in the 3-phase transformers. Okay, so we'll assume that the 3-phase power base is 300 megawatt. So it's actually the 3 times 100. Okay, and for the 9 to 9 voltage base, it is 30.8 and 38 kilowatt and 227.6 kilowatt. Okay, actually, so the one phase, do you remember the one phase? What's our base? H, right? H multiplied with the square root of 3 equal to this, and to this, okay? So that is the square root of 3 times larger than, okay? So we're assuming that operator is the Y connection. So the 9 to 9 voltage is 13.8 kilovolt. Okay, so that you will see that it will be the identical equivalent circuit in the per unit analysis. Okay, so you can remember. So the same figure. It's the same figure. Okay. For you to see that everything is the square root of 3, or then the power, then the complex power is also the 300 for 3 phase. So any questions here? Okay, it's only for one phase because it's balanced, so each phase is okay. You could imagine that we are starting the phase A. So identical, right? And we'll see that for the voltage base, okay, so voltage base is 30.8 divided by 30.8, so it will be 1, okay, 1 per unit, or per unit divided by this, okay, the same, right, the same current for the voltage of the load, right, the same calculation, and we get the same result. And for the complex power of the load and the generator, yeah, you like the same, okay? So everything is the same value. But on the last step, so when we are transferring the per unit power, per unit parameters to the actual quantities, okay? So we'll get the different values. Different like this, okay? So the actual remember that in the three-phase system, the base of the complex power you need to times or multiply with 300, because the base is, we use the base of the total complex power here, okay? So any questions about the three-phase per unit? No? Okay. So we have the last lecture note for the transformers, and then next week we will start the system structure and power flow. Okay. And of course, there is the bad news, because we will finish the transformers and the per unit transformer part and the magnetic field today, so we'll have the second homework. I'm sure that will be easier, and there will be not as many questions as the first homework. Okay, so it will be quite easier, but you still will have 2 weeks the final part of the magnetic part and transformers. Okay. So the periodic change of the mega bar base. So that in our real world, so the parameters of the equipment is usually generated using this power rating of the equipment, okay? That we will use this common power base for an example. So the impedance, okay, the original base per unit will transfer to the actual value of the impedance, and then you can get to the new base in the new per unit system, okay? So that we can just to use this original base per unit. So this page is we will discuss about the converge of from one per unit system to another unit per unit system, okay? So that V base, and this is for the original because this is the same base, multiple base here, so that the original base is the complex base, and in the new complex base in the new per unit systems, okay, we will get the impedance of the new bases in the brand new per unit systems. Okay, so in this case, V square divided by V square down, okay, so that the original base just be 2 times the ratio of the complex power base in the two per unit system, okay, the new base, the original base system, we will get the new impedance base in the new per unit system. Okay, so it's just a conversion from one per unit system to another per unit system, or we say from one base to another base, continuous base. That's why we call the power rating. We use the complex power as a base. Okay. It's quite simple. So the transformer, the power is 54 megawatt, and the leakage reactance of 3.69% on its own base, okay, on its own complex power base. So we need to convert this value to a new per unit base with 100 megawatt base, okay. See, new base, original base. Original base is 54 here. New base is 100 here. So that originally it will be this 0.0369 in the original base system, but to convert to the 0.0683 per unit in the new system. Okay, so we say that is a converting transfer from the one base to another power rating base. Okay. So that for the transformer reactance. So the transformer reactance is often specified as a percentage, okay? So that's like the power rating, how many percentage is per unit, because the per unit is, or usually it will be compared with the 1 per unit, okay? Power base, so here's an example. So the power rating base 350 megawatt and turn ratio 2 and 30 and 220 kilowatt, okay? The liquid reactance of the 20%, okay? So the 0.1. So what will the per unit value of H in the new 100 megawatt base? So what is that? Its actual values. You can easily match original per unit value.
Linkage.
And yeah, linkage the reactance. So this is the new origin base, the original origin base. So it's the new per unit value. And with the new system, right? So it will be the V voltage square divided by the per unit by the system, right? So that we will get in the 2 and 30 kilowatt, it should be approximately 15 or so we here have 3 strings we to connect the 3-phase transformers. So you still remember the Y connection? There is the delta, delta, Y to Y and delta to delta. So this will be in our real world. So measuring what way the 3-phase transformers connected, will generally use one common cause. It's actually, you see it in the figure, so it's 3 core, right? We actually use one core. And that way we will not only extend the reliabilities of the transformer, but also we could do lower down the cost, okay? And for the delta to Y and Y to delta, okay? So the company that the 4 connections in the 3-phase transformers, okay? Okay, so we have one examples. There is a Y to Y connection, right? Primary side in both in primary side and secondary side. You will see this part we will not ask you to prove these conclusions, but at least you need to have the base knowledge on this part, okay? So it's Y to Y connections. AN is the phase, right? Phase voltage. Phase voltage to the phase voltage is here the A, right? And the A is the ratio turns ratio, okay? Ratio of turns. And so VAB is the line voltage, right? VAB is the line voltage, right? It's here the A. And the current, right? The current, because in the Y connections, the phase current and the voltage current is the same way, the same thing. So the current, primary side, the secondary side is also 1 divided by A. So you see the Y connections, it should be exactly the same definition help with the single phase transformers. Okay, so it's the simplest Y connections. And for the equivalent model, we see, okay, just like the equivalent circuit of the single phase transformer, okay, impedance of the transmission line, okay. So here is the winding core, okay, winding core, and here is the winding, and here is the core, match. The same way, the phase B, the phase 3, to this. And for this, there were only 3 windings here without any impedance. So that in one per phase model, yeah, because you see that there will be 3 phases and each phase will share the same shape or the same structures of the circuit. You see that with exactly same equivalent circuit, okay? So for Y connections, so and because this Y to Y connections is the simplest connections that will be commonly used in our real world, okay? And so the P advantage, so that the Y connection, we say that the Y connection has a neutral point, so that each side neutral point can be directly grounded, okay? One neutral point grounded, both each phase can be grounded, okay? So to be much easier, and there will be no phase shift, okay? What is the phase shift? And remember, Y to delta, to Y.
Y to delta,
Yeah, 30 degree, 60 degree, that is called the phase shift. But in the same structure of 2 sides, there will be no phase shift. Okay, so it's the Y to Y.
Y to delta.
No, it should be the delta to delta, okay. Delta to delta, you see that AP, it's actually no differences because the phase voltage and the line voltage is the same in the delta connection, okay. So the voltage ratio, the ratio of the voltage is also the ratio of the turns of the each phase, okay. And for the current, you could also say that here is the line current AB, so this is the phase current IA, right, is the line current. No matter if it's the line current or the phase current, they are also the same with the single phase. Still, the equivalent internal models, okay? Impedance of the transmission line, impedance of the core, the winding, okay? And to transfer or to transfer this shape, you see here is the delta, but here is the Y connection structure of the equivalent circuit, okay? Like we could say that the transmission, actually I have to prove the transformation method of the impedance of each phase from the delta to Y to delta in the previous lecture, right? Okay. So in such way, we can just detect the image. To transfer, we will first transfer the delta to Y connection, delta to Y connection, and then we can use the same equivalent circuit, okay, but with the different impedance, resistance, and reactance. Let's say the reactance divided by 3, divided by 3, divided by 3, okay. So that the per phase analysis in the delta to delta connection is similar but not identical. The Y to Y is identical to the single phase. The delta to delta is similar to the single phase because here is a factor of the 3, okay? So everything in the primary side can be divided by 3. Okay, so because if you say that for delta, you cannot be easily grounded, so which side you can ground it, right? Here, on the face AB, will not be grounded. Here, AC, here, DC, so that the delta is partly founded in our, partly found in our real lives. Third, delta to Y connection, okay? AB to the AN, AC to the CN, BC to the BN, right? So in this case, so VAB divided by VAN, right? If you see the VAB is probably with the VAN because these two sides, this is primary side and this is the secondary side, okay? For these two sides, the ratio of the voltage is also equal to the ratio of the turns, okay? Okay, we're going to take these. But here, you can see is the angle shape, is the phase shape, right? AB is equal to the square root of 3 times the magnitude and with the 30 degree positive and the actual 30 degree shift, okay? So that the AB, right, this VAB is equal to square root of 3 times this divided by the ratio turns, turn ratios, ratio of the turns, and VNA is equal to this. Both are divided by the ratio of turns, okay? So you see that the voltage is much more complex. There will be a change in the magnitudes and also a phase shift. This part, let's say is a very single phase and the Y to Y delta phase. And for the current, this we can use in the same way. So the AD, ratio of the AD and A is 1 minus 1 divided by A, right? That the current of the 9A is equal to A times the phase AD current. However, it's current shifting, right? It's 9 to 9 current, phase current, square root of 3 times, and look that here's a minus 30 degree, okay? You can get these equations of this phase AD current. So to see that for this current A to current A, the 9 current to the 9 current here is the different. Because in the delta, line coverage is equal to the fixed coverage, right? Line coverage, in the Y connection, the line coverage is equal to the fixed coverage, but in the delta, they are not the same. So that we can get this. This is also a phase shift and a magnitude change. Little bit complex, right? Here, you see there is a delta to Y, right? In the previous page, we know that in the delta connections, both equivalent impedance be divided by 3 in the delta, okay? So here is estimation process, okay, such degree, and here is the magnitude change here for both the AN and for both the voltage and the current, okay? Voltage and the current. So that in the Y, in the delta to Y, should be a 30-degree phase shift. That this maybe with a structure with a more difficult or more complex structure, we can use to step down since it's neutral. It's a neutral on the no voltage side. Okay, no voltage. Y connection. There is a neutral voltage, neutral point here. Okay, so here is another frequently used transformers, node tape, right? LTC transformers. Tape ratios that can be varied to regulate bias voltage. So what is a node tape? Do you know? Node tape?
Node.
Yeah, node tape. What is the node tape changing transformers?
Load. Load table.
Node tape is actually the consequence. So in our previous pages, we'll assume that the A will be constant, right? 1 to 1, 1 to 2, 1 to 3, 1 to 10 should be a constant. But in the node tape transformer, it will be the variant, okay? You can see that 333, 3 steps, 1 to 1, 1 to 1, 1 to 1, 1 to 1, 1 to 2. And by doing so, we could get to regulate the load, right, to suit the different bus voltage level. So the way we put the node tape, because node tape is a consequence for us to change the ratio terms, okay? That to change is a mechanical process. So this transformer should be at 30 setting set point. So you have learned about the circuit theory. What is a deadband? Is a deadband just like a switch, okay? Just like a circuit. For instance, if we have the circuit, I have to add one switch here, okay? And for the current should be this. For this and then we have this. For this shift band. So where is the dead band? But if we add a dead point here, so what is the structure, what's the shape of this function will be? X 0, the y. So anybody knows? You don't know? that line, you could see that a time to be preparation or reserve. This put a deadline, okay? 30 seconds. You can see actually we have changed the switch, okay? But the firing or the change process will start after the deadline is finished, and then the value that we form, the value where it's changed will change from the -1 to the 1 after the deadline is finished. So that in industrial, not only in the transformers, you will see so many deadlines, just like circuit breakers, okay? You know, yeah, you need a time to prepare or as a reserve, okay?
This also relays the deadband.
Yeah, relay, of course, relay, circuit breaker, relay, just like the same.
EMOS.
MOSFET,
Yeah.
different? You mean the difference between the transformer and the relay?
EMOS. MOSFET, I mean. MOSFET.
MOSFET.
Yeah.
Oh yes, you mean the power electronics. Oh yes, of course.
MOSFET is also.
Yes, I could mean that there will be so many different types of the equipment, but the deadline, this idea is the same, okay? So provide some time for reaction or the preparation, okay? So the unbalanced heat positions versus the circuitry circulating bars, okay? So reactive power will flow one winding to the next, okay? So that's over. So here's the phase shifting transformer, okay? So what is phase shifting? We say that this is the phase shifting transformer. That's where it be the shift of the 30 degree, okay? So that is shifting, the phase shifting transformers is used to control the shift angle, okay? So the LTC is to control the magnitude, okay? Because it controls the turn ratio of the panels, okay? But for the phase shifting, it controls the phase angles. So phase angle is actually very important in the power flow, and we were just to start to learn the power flow since to maybe I will try to finish it in 2 lectures, okay? Flow, so that phase shifters, which will be used to prevent the loop flow and to prevent this line overloads, okay? The power flows. And for the power flows, we will just to discuss this later, okay? So let's see the very large volume, okay? Large volume, very large size in the phase shifting transformer, okay? So auto transformers is quite smart, is more smart, okay? So anyway, you know that here is the transformer that can to change automatically, okay? So here is the 15 minutes. And are you feel tired? If you feel tired, we will just to continue our topic in a smart way. But if you are not tired, we will still start the power flow. But it's up to you, Lashi.
Hungry.
You're tired?
Hungry, Lashi.
Okay. But actually, so because we have the 4 classes in 1 week, it's a little bit challenge to finish everything in 1 morning. Okay. So let's get something relaxed. Relaxed. project here. Okay, so in the previous
I'm done.
okay, so we will have 2 minutes break. Okay.
Okay. 2 minutes break is slowly.
Yes, because our department asked me to attend the assembly this afternoon, so that you see why there will be so many phone calls to this.
Why did they send it?
We assembly for
December?
the normal cameras for our state grid
Oh,
corporation because they will prepare a program to about the distribution of data money.
oh, this building.
Yeah, building
Oh, yeah.
distribution, so that in this afternoon, so I have to send them my, you are healthy QR code.
Yeah.
If you are from your side, please showing your QR healthy QR code to prove that you have no coronavirus in your body, so that okay, testing your green code, right? Yeah, of course. You need have. If you do not have, you will just to send for a compulsory 14 days hotel vacation, right? And you need to pay it. Why is that? Yes, of course. Okay, so of course you need it. Just so that if you are
So, sir, what a time you will, they will be start this experiment or assembly of high voltage.
experiment.
Yeah.
So what experiment?
No, you say you have a assembly today.
Happened today. So I'm not sure because the staff there, the people there just told me that we were discussing about one program. They were just wanting to start a program about distribution at work, but I'm not sure what the details. So this afternoon, maybe I will just go back to downtown because there is corporation building is there.
My one friend, he also told me this.
Okay, ready?
He- Yes, can you do me? Do you know him, sir?
Mm-hmm.
Do you know him? He was there.
Working there?
Yes.
We not know him.
A lot of students there.
Oh, they are quite stretch of this.
That's a Bangla citizen. Same person. How do you Google Salem? Google Salem. अभी Google অনেক চেষ্টা করছি সেটা নেই না
দামি কোন গেলে হবে দামি কোন গেলে লাভ আছে
He's no height teacher, yeah.
Mm-hmm.
You're on height. You also can use Google. I also
you need
can
a break here.
No, this phone can support this Google, the Play Store. I have this one. Google তারা আবার এক মজা বারবার নেট নেট উল্টান লাগে না তো ফেসবুক চলো
শান্ত না নিজেকে শান্ত না
It's actually the Google, so for the Facebook. So in my previous, maybe 2 months ago, when I was in my PhD college, so the Google can be used if you connect with our campus network, and for some time, what we do is we know if our government will start to assembly a meeting, maybe on the March or on the January, September. So you know the trade fair will work more effectively. So that during that period we cannot use it without a VPN.
This is Huawei, so this phone can support Google.
No, you need a VPN.
I have VPN.
Oh,
I use VPN, but
no.
I can't install Google anywhere. I can't install.
What's your model? So the P.
Huawei.
No, the Huawei, the
Yeah.
P40, the P or the Max,
Nova.
Nova, and for when you purchased it, when you purchased this
1 month ago.
2 months ago,
1 month ago.
Oh.
I was.
but you can just use it in your Safari. You mean your Internet Explorer?
No, I mean this direct Google. This is.
I know. So the Huawei is blocked by Google, okay? But my phone is because my cell phone is purchased 2 years ago. So in that case,
So you can,
yeah, of course, but you can use it in your web
but I use
laptop. Okay. So let's start. Okay, let's start with this range. Okay, so bounded range, the unbounded range, you have to remember so that this will be the fixed prices, is the unbounded or the more flexible prices. In the more flexible prices, the more power you use, the more money you save compared with these bounded prices. Okay. So here is the detailed change, okay? So the unbounded total and the bounded prices. There's to be differences because here is the fixed fee charge, okay? So the certain revenues. So the revenues means that no matter what things happens, how many people, how much power you use, this part of this money you will get because if there's the fixed charge amount and you connect to other corporations, you need to pay for the proceed that monthly fee is $20. Before you start to use this power. Okay, so here is the totally 200 mid-wash money is connected. Okay, so this is called the revenue subsidies. Okay. Okay, next we'll see that the demand charge say hours of day, at night. Okay, so everybody will go back to the dorm, I go back to my home, however, we spend more money, or consume more electricity during the night time, okay? And for large consumers, not consumers, just like the mall or in factories, you see that we almost the same and even much lower in the midnight because they are not running their activities during that time. Right. Okay. So here is an example of the TC rate. Okay. You see this is the residential demand. Actually, in some provinces in China, you choose to apply to the state grid, and you ask them to change you the meter, and then you will be charged the flexible rate or prices of the electricity. But in Hunan, currently, at least in the 2020s, they do not expose such applications because in if in these flexible presses, you see that in this time, the prices will be get high, but however, at this time, the price will get much lower. So if in the winter, I will say that this time, maybe I will be working or in the building, in the campus, so that the electricity charge with the lodge, I do not need to pay for the check, the electricity charge. But in the next time, I will go back, then I will go to the back, going back home, 23, I go to back,
And you
then,
have to be paid.
no, yeah,
They have to be paid.
it's a time to turn on the air conditioners.
Yes.
But if I can get the flexible prices, there will be much more expenses I have to pay during winter. But unfortunately, our provinces do not export such offers or such applications yet. So maybe in the future. Okay, so here is the range, right? You can see the conventional, e-heating, e-draft, e-saver, small power, market power, large primary, industrial. In right here, you can see from this part, the service availability charge, service availability charge. Okay, so you can see that is the monthly fee for the industrial, much more expensive. I will say that there will be 4 options for the residential, and maybe you could see the SAM. Okay, so for this e-saver, you could see only $90. And conventional, most expensive, $2.50 more per month. Okay. So the delivery charge is so this is called the service is so what in this case, I'm not sure why there should be some videos where choose this one. I'm not sure because at least in this page, so the fixed charge is different, but I guess this base power charge or adjustment charge will be some differences, but however it's not. So everybody should choose this, okay? And but you can see other than the residential, residence, for the small power, that power and industrial, more expensive. You can see the delivery charge. Their charge for this large commercial use is expensive.
No delivery charge.
Yeah, delivery charge. I'm not sure why the T6 would be one operations. Okay, so here they are rated prices. Demand charge. So demand charge is not required to the customers, but required by the commercial use. But you already know in industrial. So
Is less for industry.
yeah. However, maybe demand charge, because we will see that the demand will be fluctuating, more in the larger magnitude. I'm not sure why so much. Very cheap like $3 and 0.8, and not per or not it's per kilowatt. Okay, so it's will be much more expensive, but I'm not sure what quantity it is. And for the transmission, so will be the same, okay? So everybody is equal and fine to pay the same money. For the base power charge, for the adjust power cost adjust, okay? So maybe here is some discount if you use your electricity, me in the low demand period. So in America, so some corporations will give you some rebate. Have you prefer such way to get a promotion? And this is not commonly used in China because if you purchase a laptop, maybe $1,000. I say $1,000 here. And in some promotion day, just like the Thanksgiving, okay, Black Friday, you will say, okay, as long as you have a sign or the laptop delivered, so you will get $100 rebate. But it's much more, it's a little bit more difficult, and it will spend some more time. You need to assign a very detailed plan form, okay? And then you fill every blank, every part you need to sign. And here is the printed blank form or the printed form, and you send it out by the post mail, and then they receive, and then the corporation will send back to you a check. So the check, you know the check, right? Check is actually not quite commonly used in China. We use the cash or the non-money car, because it's the electric fees, okay?
Easy Alipay or
Alipay, yes, but in America we will use the check, okay? Check just like they will get you
I know
one bunch of check, okay, your check you will sign in, and you will just to write down how much money for check, and then the receipt, when other people receive your check, you get to go to the bank to exchange the check to the cash. So that the rebate is very difficult, or receipts will spend you a lot of time, because you fill in the blank of the form, okay, send out to the corporation, and then send back you a check, and then you need to get the check to the bank to get the cash. So that's why you can see the adjustment here. So they will make the rebate progress of the rebate very difficult. So that's why we call price discrimination. So if you at the beginning of the class I will say that the Double 11 day, you know,
Yes.
November 11th will be big deal in the Timor,
Wow.
so maybe here special offer. In China, we will also use making the very complex calculations methods. It's like if you purchase more than 300, there will be 40. I think for this year it's 40 yuan discount. Okay, but also they will have some coupons, right? Coupons will be the 100 to reduce 10, and here is also a promotion for each shop, right? Each shop in the website, you will see that maybe 200, you will get 15 yuan reduced. So very complex. So that's why we call price discrimination. For the millionaires, the rich man, they do not care, okay? So you say, wow, it's only 100 yuan. Wow, it's maybe a very little bit money, because I will spend 100 yuan for every day's breakfast, okay? So we say, for the riches, they will not prefer wasting time on this money, okay? And if, for me, if I do not get so much salary, so I'm not rich as a rich man, so maybe I will spend more money to get more prices. That's why we call this is the commercial items we call the price discriminations. Just to make sure that they get more revenues from the riches. But the price discrimination is a very good way just to distinguish the riches and the poor people. Okay? So here the values. So all classes, area mapping, service availability chart. You can see in the Americans, so in the total charge 3 values. Near capacity near charge parts, power cost. So the different case of the consumers, that's like the red range, that's like the small business, large business, or the power plant. So it's very different. So what you can see that in the Americans service available charge, you can see that the resident and small powers is 13%. It's a relatively very high percentage in the contribute the revenues. So that for one thing that American people were living a very, or say very, from my view, they are living in a very wasteful lifestyle, okay? And we know that for the night, for the night bar, for the air conditioners, so they were just turning on for all day in the whole year, so that they will consume much more powers than us, and also the prices is actually more expensive than us, so that more revenues for the resident. But in China, so our street will get the revenues mainly from industrial.
The
Thing
you were saying.
the service ability charge, but the power cost is much. The DG is the distributed generation, okay? That without the distributed generations, so the power needs to be transferred during or through the efficient network, so that you see that with and without distributed generations, the demand of this logical measure is much more different, okay? So this is the received power and this is the delivered energy during the different time, okay? Okay, so here is the commercial prices, okay? Demand charge, zero charge. This is very complex.
Yes.
Okay, so next check the time use range. Okay, so we discuss during the previous lecture. You know that the prices, the rates for the resident, they're a different from time to time. Okay, so say that in the non-summer seasons, yeah, it's a quite smaller fluctuation of the prices, but in the summer vacations, maybe American people will prefer to use more electricity in the afternoon, yeah, say the 15 to 18 highest, but in the midnight, we pay less than this afternoon. Maybe sometimes, maybe most of them were just to lay off or go back home at 14 to the 15, so that this price when we come as the staff get back home, we will have to pay the highest prices for the electricity, okay? So the COU rate is the time use, that describes the different time prices, right? COU rate is designed or is used to match the market prices and to send a signal to the customers, allowing or persuading the consumers to control and manage their energy use and associated cost. Okay, that's my their big load period. The house price, maybe some people there do not have so much money, but just to save some electricity, just to turn off the conditioners, okay? Then we will save some more money. And for this match, okay, so if you wish to use more electricity, because here is such a low load with no demand, so we can use during this video knowledge. So here is the billing. Okay, so here is the billing prices. You remember to see these people in saver. So if you remember, so in saver we will see that is the cheapest because here is only $20 fixed fee per month. Okay, and this family will use 75 kilowatt hour total. And here is comparing their monthly use. Okay, you see August, September, July. And for the March and April, maybe this family will choose to going out for 2 months of vacation, or they move to the new another home. I'm not sure, but there is no electricity use in this. Okay. So for actually, I think so. The billing for this billing sheet, I think it's one of the advantages for the power package in the United States, okay? Because there is a power package, so there is a competitiveness between different corporations, and you will get more better services, okay? No matter, maybe though you need to pay more high prices in China, but however, the services there is better. You see, for your beneficiary, you will know everything you need. But in China, there will be only one message. Sorry, your balance is almost zero. Please submit, please charge the electricity fee as soon as possible. Okay. You only know that you are power, you need to pay more, okay? But for here, let's see that everything, the service availability charge, the delivery charge, the base cost charge, okay? So the super economy secondary, what is to be recognized. The paid secondary, to say most expensive, and but they are using more of secondary highest power electricity and the transmission cost, okay? So the adjustment maybe is coupon or badge for they use the power in very quite low demand, right? And renewable readers, okay, so the power charge, okay, so you pay $93 per month. So for the March, right, for us it's very expensive because you say you're almost pay 600 yuan, okay? It's almost approximately $100, but I think it's acceptable for us because I'm not sure this is a family or it's a individual, okay? Also, you can choose your own corporations, okay? So like Energy, Expresses, it's something, can, okay? So different prices. We say that this price is more expensive than this Map Energy, more expensive, much more expensive, right? So that if we choose the cheapest one, the left energy, okay? Or you can see here is the 100% renewable generations and zero stage. There is only 6%, 19%. Okay, it seems that the left energy rating. This is a very suitable choices. Okay, so if we choose the left energy options, so here is the contract. Okay, contract before you choose and start their services. Okay, so everything you need to know. And here is the net energy options. Okay, so here is the cost. Here is the effective rate. Okay, monthly usage. If you use quite low, you'll still spend more per megawatt. But if you consume more, use more electricity, it will be much more mass, much more cheaper. But if after you have used more than 800 or 900 here, okay, so then you cannot save more money or save much more distinguishable amount of money after even if you use more. Okay. It's the hourly energy usage. Okay, so it's the second energy range. Another second energy range is another operation.